In this video, we're going to look at the relationship between Ka and Kb for a pair of conjugate acid bases. In the example, we'll look at ammonia, NH3, a base, and ammonium, its conjugate acid, NH4+. We want to figure out what is the relationship between the acid ionization constant Ka for ammonium and the base ionization constant Kb for ammonia. We'll start by writing a reaction where ammonia reacts with liquid water to produce ammonium and hydroxide. The Kb for this reaction would be the concentration of the products over the reactants. This is a Kb because the species that is reacting is a base. We're also going to write below that the equilibrium reaction between ammonium reacting with pure water to produce hydronium and ammonia, and we'll write the Ka, the concentration of the products over the reactants, for this reaction. Next, let's sum these two reactions and write the reaction quotient for the sum. Notice that this reaction quotient is actually the product of Ka and Kb from above. When we sum reactions, we multiply the reaction constants. If we look at the new K for the sum of the reactions, we also notice that several of the variables cancel out, and that the ammonia and the ammonium cancel out, and we are left with the concentration of hydroxide and hydronium. What this means is that for any conjugate acid-base pair, the Ka times the Kb equals the concentration of hydroxide times the concentration of hydronium. Or another way to put it, the Ka times the Kb always equals Kw. Here's an example problem. The Kb for ammonia is known to be 1.8 times 10 to the negative fifth. What is the Ka for ammonium, its conjugate acid? To calculate this, we simply use Ka times Kb is equal to Kw, rearrange the expression solving for Ka, and plug in our known value of Kb.